Let's take a look at your chapter 6.4 notes on combining random variables. So in 6.3, you started to take a random variable and you were transforming it, either adding or subtracting something to it or multiplying something to it. And we're taking a look at how does that affect your mean and standard deviation of your distribution for your random variable. Today, you're going to focus on combining random variables. So what we're going to take a look at is what happens when we start to combine two or more random variables. There's many interesting statistical problems where you actually need to do that. So what we need to do is take a look at what happens, or what do we need to do with the means, and what do we need to do to calculate out the standard deviations of those distributions when we combine random variables. Well, when we take a look at the means, sorry, it jumped there here. For the rules for the means is pretty basic, simple, and pretty straightforward and pretty logical. If you're combining two random variables and you're doing it by addition, so right here, the total would equal combining the random variable of x and the random variable of y. To find the new mean, if you want to call it t, you simply just add the means together. So whether you have two random variables, three random variables, 10 random variables that you're all adding, okay, you would just simply add the means. Okay? Same thing works for the difference. So if you're looking at the difference between the two means, okay? So if you're taking a look at two random variables and you're trying to see which one might be better, so you might want to subtract the two to see which one, is bigger than the other. Just to let you know, a little typo here. Change that right there to a D, just a small little typo that we caught. But with means, it's very simple. You are simply subtracting the random variables. So addition goes with addition, subtraction goes with subtraction with means. Now, when we take a look at standard deviation, just like we did when calculating out these random variables, we really calculate out the variance first. Okay? So, in order to combine standard deviations, you actually have to combine variances first. So, not only that, but one of the things that you want to make sure is that the two random variables, and you just need to verify that they are independent random variables. Because if one random variable has an impact or influences the other, okay, then you really can't combine the distributions, because it could, the standard deviation or the variance of the one is being influenced by the other. So, similar to the mean rules, when dealing with addition of random variables, when you're combining those, okay, you simply combine your variances to get the new variance, and then take the square root of it to get your standard deviation. Here's the difference, and here's another little typo. This should be D, apologize for that. Is when you're taking the difference between two random variables and you're taking a look at the variance, it's not subtraction. You are actually putting the two spreads together, so you're technically really adding them. You're not actually subtracting them. What helps me to remember this is if I were to actually do subtraction and I actually subtracted the smaller one then the bigger one, I would get a negative number. And there's no way you can have a variance that is actually negative. Okay? So when you actually combine random variables, adding or subtracting, and you're looking at variance and their spread and you're putting them together, okay, you must add them. So now, just one last little thing here is just to note, sometimes you'll be given the standard deviations in your problems. You can't add those together. You actually have to convert them to variances, combine them that way, get your answer and take the square root to get your standard deviation. So know this piece. Know it, love it, make it your best friend. All right, so let's take a look at some examples and put these rules together. So in number one, it's going back to, again, the El Dorado Community College, and it gives us this new random variable B. It says the amount spent on books for the fall semester for a randomly selected full-time student at El Dorado Community College. That's what B equals. Suppose that the mean for the cost of books is $153. So over here I'm going to write 153. Standard deviation is $32. Likewise, recall that the overall cost for tuition and fees for a randomly selected full-time student at El Dorado Community College has a mean of $832.50 and a standard deviation of 102.80. So in A says, find the mean and standard deviation of the cost, tuition, fees, books, meaning basically find C plus B for a randomly selected full-time student at El Dorado Community College. So to find the mean, so we're looking at the mean of C plus B. That's just simply going to be the mean of B plus the mean of C. Sorry, I flipped those around, but with addition, it won't matter. So I'm just adding those two random variables together. So again, our cost for books was $153 plus tuition, $832.50. So if you add those together, $985.50. So that would be the mean cost for both tuition, fees, and books. That would be the average cost. So for our standard deviation, okay, we would actually try to calculate out the variance. But again, we always want to, and here I'll put them in the correct order, C, B, but again, addition actually would matter. We have to check for independence. Does the tuition, which is actually based on the number of credits you're taking, impact the amount you would spend on books? So in this case, it actually does influence it. So these two events are not independent. Hence are not independent. Therefore, we cannot calculate out the standard deviation. And again, the reason why you can't is books are actually, the cost of our books and the spread are going to be influenced by the overall tuition cost, because again, tuition cost is based on how many credits you take. The more credits you take, the more likely you're going to have to spend on books. The less credits, the less you're going to spend on books. So therefore, it would not make sense, since they're not independent, to calculate out the standard deviation. However, we'll do some where we actually do. All right, so in B it says, El Dorado Community College also has a campus downtown, specializing in just a few fields of study. Let Y be the number of units taken at a semester by a randomly selected full-time student at the downtown campus. The mean of the distribution is 15 units, so the mean of Y is 15, and the standard deviation is 2.3. At the downtown campus, full-time students pay $55 per unit. Let U be the total cost of tuition for a randomly selected full-time student at the downtown campus. Find the mean and standard deviation of U. What I like at least about this problem is it's a nice review of your linear transformations in 6.3. So the first thing I need to do is define U in terms of T. Well, I'm sorry, in terms of Y. Y again being the number of units taken. I'm going to multiply it by $55 because that's how much it costs for each unit at the downtown campus. So my linear transformation here is just simply 55t. So what I need to now do is calculate out the mean of U. So according to my linear transformation, it's A times the mean of Y plus B Well, the only value that, I apologize, I flipped those variables and I do that all the time. So let me just go back and do a quick correction. So it's actually A plus B times the mean of Y. So A, we have no adding and subtracting, but B is 55. This is our B. So for the mean of U, it will equal simply 55 times the number of credits, the average number of credits. So the average cost for tuition for a downtown student, if I actually multiply those together, $825. Now the standard deviation for C will actually just equal the absolute value of B times the standard deviation of Y. So in our case here, for the standard deviation of C, we're going to get the absolute value of 55 times 2.3. So we get $126.50. Again, we take absolute value so that our spread or measurement or standard deviation here, measurement of spread, is 126 or is a positive value. Okay. All right, so now question C, we're finally going to get to using our rules that we just talked about. C says calculate out the mean and standard deviation for the total amount of tuition for a randomly selected full-time student at the main campus and for a randomly selected student at the full-time campus. So what we calculated out here is downtown. These values that I kept here, I can go back to 6.3 and just look at the cost of tuition. So these values here represent the main campus. So this up here is the downtown campus. So I want to calculate out the mean and standard deviation. So basically I'm looking at what is the mean of the main campus plus the downtown campus. So what's the mean of T plus U? Well, that should equal simply the mean of T plus the mean of U. So if I take the mean of T, 732.50, plus 825, add those together, I get $1,557.50. Meaning if I had like one student going to the downtown campus and one student going to the main campus, the average tuition cost for those two students would be $1,557.50. So now I want to take a look at the standard deviation. However, to do the standard deviation, I have to do the variance. So I have to take the variance of T plus the variance of U and calculate that out first. So I'm going to take 102.80, square it, plus, and then I calculate it up here, 126.50 squared. So I want to calculate that out first, and I get $26,570.09. That's my variance. So to get the standard deviation, I would take the square root of that value, 26,570.09, and I would get, and what's really nice is when you plug this in your calculator, it ends up being $163. It actually rounds to a nice $163. All right, let's flip to the next page and continue on here. Just got a couple more examples. We're going to continue on here with still this example here. It now says, suppose we randomly select one full-time student from each of the two campuses. What are the mean and standard deviations of the difference in tuition charges? D meaning T minus U. Interpret each of these values. So one of the things I haven't been doing is writing it, but telling you what it actually represents. So let me at least write those out also here. So the first thing we want to do is we really want to calculate out what's the mean of T minus U. So we know that's going to equal the mean of T minus the mean of U. So when we calculate that out, okay, $732.50, again, just using the values from our previous problem, minus the $825 for a downtown, the mean, and I get a negative $92.50. Your mean can be positive or negative. Okay? It just means one mean was bigger than the other, or one's tuition was greater than the other. So what does this value mean? Well, on average, we can say the cost of tuition oops, I think I'm spelling tuition wrong, but I will, yes I did, sorry, flip that around, get rid of that T. The cost of tuition, so on average the cost of tuition at the downtown, or let me say the main campus, will be $92.50 less than the cost at the downtown campus for a randomly selected student at each campus. So if I were to randomly select two students, the average difference in the cost of those two tuitions is going to be $92.50, but we want to say the main campus is going to be $92.50 less. If you said the downtown campus is $92.50 more, that would also be a correct interpretation. All right, so now this is one where we can calculate out the variance or the standard deviation. And I didn't mention this in the previous problem. The reason why we could in the previous one with the addition was that the two events are independent. A student taking courses at the downtown campus shouldn't influence students taking courses at the main campus. So in this case, now we want to calculate out the variance between the two. So in order to do so, we calculate out the variance of the main campus and the variance of the downtown campus, and we add them together. So here's the nice thing about this. We're just going 102.80 squared plus 126.50 squared, which was the exact same calculation we just did on the previous problem. So I know that this is $163. So what we can say here is, on average, the differences in the tuition cost between the two campuses will vary from the mean by $163. So what's nice is, here we're comparing two schools. You can see which one costs more on average, but you can also see there is variability here, and the average variability, the average difference between the two will differ by, or will vary by $163. So even though one costs more than the other, okay, our standard deviation is actually $163. So there's going to be times where you could randomly select a student from the downtown campus, from the main campus, and it would be more expensive than those from the downtown campus. All right, so let's take a look at our last problem where we can actually combine means and standard deviations and then use a normal calculation to figure out a certain probability. So, it says, suppose that a certain variety of apples have weights that are approximately normally distributed with a mean of 9 ounces and a standard deviation of 1.5 ounces. If a small bag of apples are filled by randomly selected apples, what is the probability that the sum of the weights of the apples is less than 40 ounces? So, one of the things I'm going to do is I'm going to define my random variable x. And x is just going to be the weight of a randomly selected apple. So now what I want to do is I want to find, okay, the total weight. Okay? So what will happen is like x1 will be like the first apple, all the way to x sub 5 being the fifth apple. So one of the things I want to find is t, which would be the total weight. Well, what makes up the total weight? Well, t is actually will be equal to x1 plus x2 plus x3 plus x4 plus x5 because I'm adding 5 apples to the bag. So this is one where I'm combining 5 random variables. So to get the mean of t in this case would simply equal the mean of x plus 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 the mean of x. And I suppose x1 plus x2 plus x3 plus x4 plus x5. But what we know is all of those means are equal to each other. So really, the mean is going to be 9 plus itself 5 times. Some of you are saying, well, couldn't I just go 9 times 5? In this case, you could. So the mean is 45 ounces. Now, if I want to do the standard deviation, I actually have to calculate out the variance. So I have to take the variance of the first one, and the variance of the second one, and the variance of the third apple, and the variance of the fourth apple, and the variance of the fifth apple. So in this case, I'm going 1.5 squared, and I'm doing that 5 times. I hope I can squeeze it here. It doesn't look like I'm going to be able to. Plus 1.5. So if I do that, the variance is going to equal, if I remember correctly, 11.25. And then I want to take the square root of that. So the standard deviation of t, for some reason, I don't know why, I don't have that written here, so I'm going to pop up my calculator here and just do the square root of 11.25. Whoa, let's try this again, calculator. Square root of 11.25, 3.354. So now, I have the mean and the standard deviation. I want to find the probability that the sum is less than 40 ounces. Okay? Now, to calculate that out, if I go back up here, it says approximately normally distributed. Hence why I was finding my mean and standard deviation, because really, I want to know what's the probability that my total weight is less than 40 ounces. So if I'm visualizing this here, here's my mean, right, which is 45. I'm trying to look for 40 or less, where I have a standard deviation of this 3.354. So that's telling me z-score. So z equals my score, which is 40, minus 45, divided by my standard deviation, 3.354. So when I go to calculate that out, 40 minus 45 divided by 3.354, and I get negative 1.49. So I'm really looking at what's the probability that my z-score is less than negative 1.49 standard deviations away. So we know we can calculate that out using normal CDF or table A. So our lower bound is negative infinity, upper bound is negative 1.49. So quick calculation, second bars, normal CDF, negative 999 to negative 1.49. Go ahead and hit enter, 0.068. So we would say probability that a randomly selected bag of 5 apples is less than 40 ounces is 0.068. So this, if I'm a business person, I'm a person who sells apples, and I want to guarantee that all my bags, okay, are less than 40 ounces, according to what I have here with the average and whatnot, almost 7% of my apples on just taking random samples are going to be underweight. So this is how businesses can start to take a look at how they use this. And so when they're advertising, this is a 1 pound bag of carrots, or this bottle has 20 ounces of water in it, okay? They're using these values or these calculations all the time. All right, that ends your 6.4 notes. Go ahead and start working on your CFUs and your homework. Good luck.